There's a great phrase. Thank you for that, Elizabeth. These two statements are actually equivalent to each other. Yeah, they say the same thing in two different ways, right? Because, for example, simple example, gas is always people always talk about gas, talk about inflation. So when my band was going on tour back in the '90s, exactly, we could get. I had a Ford Econoline E150 with straight six engine. They got about 16 miles a gallon. Well, it was actually pretty good. It was actually about 16. When it was loaded down, it was more like 9. But straight six engine, the workhorse. We did hundreds of thousands of miles with that van. Gas was about $1.05 a gallon. That's insane. Nobody's seen gas that cheap in decades. Which means, this is hard to think about, but we could go to the gas station with $1 in the '90s, pay $1 and get a gallon of gas. Now, if you tried that, took $1 at the gas station, how many gallons of gas would you get? About. They'd shoot you. Well, assuming they didn't shoot you, that'd be dangerous around gas. Like a third of a gallon, it's about $3 a gallon now, right? So you get like you get about a liter of gas versus a gallon. So that's the decrease of the money's purchasing power. Same dollar buys less stuff. Why? Because of the increase of the price. Both of them, this is so tight now. Both of those things are good. Love it. Both of those things are good. What'd you find, Christania? Excellent. The CPI, consumer, and I'm not going to get into this too much because it's not a business class, but that's 100% correct what you said. CPI is a consumer price index. Consumer price index. We're actually going to look up something. We're going to be able to find something called the CPI calculator online, which means the U.S. government has done the work for us for inflation over the past 100 years. It's great, exactly. Our tax dollars are paying for something useful. You mentioned it measures the cost of a. That's okay. Get back if you don't mind. And don't write this down. It's a group of goods and services. So, has anybody ever done a cost of living comparison in different towns to see if they can afford to live somewhere? Anybody done that? Yeah, absolutely, absolutely. Certain towns are more expensive to live in than others. I'm actually designing a problem for your in-class part of your exam that looks at COCC's tuition versus the other 16 community colleges in the state, but not just raw dollar amounts, also how much a dollar can buy you in Central Oregon versus, say, Tillamook Bay, or Pendleton, or Ontario, or Newport. I'm trying to think where all the community colleges are, the towns where all the community colleges are. Oregon City, Astoria, that's where Clatsop is. So anyway, I'm working on that problem right now. It's pretty labor intensive because I have to go find all their web pages and pull all the tuition down. Get there. Yeah. So, but the CPI is basically the tool they use. They ask things like, what does a loaf of bread cost in these places? What does a gallon of milk cost in these places? What does rent of a studio apartment cost in these places? What does electricity cost per kilowatt hour in these places? And then they put all those together and come up with what's called the consumer price index for a given town. Basically, if two towns have the same consumer price index, they're a 1-to-1. But some towns have a less than 1, which means they're cheaper. This is what I might make a problem out of this in the partner party. We'll play with that. Thank you for that. That was great. Anybody else? Yeah. Does anybody know, and if you pay any attention to the political garbage of the past 6 months, you've probably heard this constantly. What kind of math is used to measure inflation? Ups and downs. It's a type of math we actually looked at in the homework from last night. And when I say type of math, let me rephrase that. It's not really type of math. It's a certain kind of number. Somebody just said it. Say that again, Joseph. Shannon's over there. Joseph's over here. Shannon, say it again, Shannon. It's percentages. For example, 2 weeks ago, inflation slowed to only 2.2%. Oh, but then it ticked up to 3.3%. So inflation is almost always measured as a percentage, not a dollar amount. Always measured as a percentage. And that's what the rest of the homework we're going to play with, is practicing the mathematics of inflation. And then the rest of the day, we're going to play with those numbers in context. So one of my favorite memes of all time. It's getting pretty old now, but it's still relevant, I think. We'll get to that in a second, though. So if you look at the next, let's review here what you got. If something costed $2,000 in April 2022, I went with April here because I was using the old April numbers, and inflation over the following year was 4.93%. How much should it cost in April 2023, assuming that it followed inflation perfectly? How would you do this? Oh, I love that. So slow that down, Natalie. Slow that down. Slow that down. Hang on, hang on. So Natalie is telling us how to do this. April 2022, $2,000. If we want to go to April 2023, give me that whole math. Give me all that math again, Natalie. $2,000 times 4.93%. Stop right there just for a second. I like writing these as decimals instead of percentages, only because my brain has been trained to do that. So when you see me write a decimal, you can change it to a percentage. Just realize, I write these as 0.0493, correct? 4.93%. You can write it as a decimal as long as you can get the calculation correct. Now, what did that come out to be? $98.60. Okay, so that means it costs $98.60. No! What is that though? That's the inflation on the 2000. So in order to get the actual price in April 2023, we have to add that to the original 2000, yes? To get $2,098.60. Would anybody do that a different way? I'm going to show you a second way. And we're going to see. Well, because it's actually quicker.
Love that German.
How's that? What? Well, let me show you. Natalie's way, perfect. It's perfect. Perfect. Another way you can do it is start with $2,000. And go ahead, Josie, what do you think? Do that. Do that for me. 2,000 times 1.049. Do that for me, please. What do you get? What do you get? No, just trust me. Good. Good. What do you get right here? 2,000.
2,098.
That number sound familiar? That number sound familiar? Sure does. That's the same thing Natalie got, right? Oh! What's that treasure you? Where does the 1 come from? What does the 1 mean?
2,000 that you asked.
It's the 2,000. The 1 stands for whatever it was before. The 0.0493 is the extra percentage that it inflated. So in other words, that 1, Mel, remember when Natalie added 2,000 right here? That was really times 1 because that's 100% of what it was back in April 2022. You didn't get that in your mind. You just said, oh, I know it's going to cost at least that much. That's what the 1 is. The 1 is at least that much. The 0.0493 is that extra bit of inflation. You have to do it this way? Of course not. You don't have to do it this way. But that makes the math quicker. And we're going to see those ones as we do math today. So I wanted to make sure we saw them first before we went any further. You don't have to like it now. It's okay. You don't have to like it. You can do it your way. I just want to show you 2 different ways. Okay. Ready for this? Yeah, you are. Try number 2 now on your own. If something costs $2,098.60, in April of 2023, and then cost $2,400, jumped up, which sometimes happens with prices of goods. In April 2024, what was the inflation rate over that year in 2023 to 2024. So this is a little bit backwards. I'm telling you what the actual cost was the following year, and you're going to tell me. You're going to tell me what the inflation rate was. This is what economists have to do, because they can track the prices of goods and then report back on the inflation rate. I'm not going to tell you how to do it. I want you to do it any way you're comfortable doing percentages. I'm curious what you end up with. Woo!
I like this too. I like this too.
So what is that? What is the percent? What is the percent? Oh, that is so 3.014%. Jordan's got a vote. Jordan's got a vote.
I'm not putting money on that.
That's all right. We're gonna put money on the vote together here in a second. We'll regroup and we'll do this together. Yes. Oh. Love that so much. I don't know. I haven't done it myself yet. What's that? So I'm seeing a couple different folks attacking this a couple different ways, and that's okay, because it really depends on how you do percentages. This is a math topic from well before Math 105. We're just pulling it back from the back part of your brain. One way, Josie said, and we'll like a couple more minutes. Keep working. Give me a thumbs up when you think you have a number, and then we're going to come together and we're going to chat about good. 100% not right. Okay, that's good. Okay, Hannah, thank you. Josie said she wants to reverse engineer. She wants to reverse engineer it. I kind of like that, because if you think about how we just did that one, I'm going to up here real quick. If you did it kind of Natalie's way, which is awesome, you had a starting value. So in the previous example, it was $2,000 in April 2022. Then, to inflate it, we took that starting value, and then we added it to the same starting value times the rate of inflation. Now, that's what you did. So in the previous one, before number 2, you started with the starting value of $2,000. And then you took that $2,000 and multiplied it by the rate of inflation. Josie and I had an idea. I'm not sure how many of you liked. You can also do the exact same thing in one move by taking the starting value times, now, you might not like this at first, 1 plus the rate of inflation. These are the same thing. It's just this does it in one step and that does it in 2 steps. Now, give me some ideas. How did you do number 2? Hannah, help me out. I like it. So I saw a lot of people doing this. I love it, by the way. I love it. Hannah took $2,400 and subtracted what it was a year ago, which was the $2098.60, and you got $301.40. Love that. So that's the amount. That's the dollar amount that it inflated. Good. We have to respect it. We have to know that as a percent of inflation. So what'd you do then?
And then I took 2,400 and then divided it.
Say that again.
So I took 2,400
Uh-huh.
and divided it.
And what did you get then? 7.96. So, okay, hang on, hold that thought now, hold that thought. If we take $2,400 and divide it by 3,014, the number you get is 7 point something, something, something. What's that as a percentage? That's actually 796%, isn't it? Because to change a decimal to a percentage, you have to move the decimal 2 places to the right. God, I hope inflation wasn't 800% over the course of 1 year. Ugh.
I don't know why I'm thinking this, and maybe my brain is too.
Uh-huh. No, go. Why? Where's that coming from? I need to know where the numbers are coming from.
Okay,
Look, Melissa.
so I did the opposite, so I did everyone.
Okay. Everybody agrees this is how much money it went up.
But
Oh,
divided by 24.
Okay.
Flipped it, and then times it by 100, and ended up getting 12.6.
I love that. Say that again.
Is it by 2,400 or
Here, this is the discussion I was hoping we would have. The math you just described. First of all, rate of inflation is a percent. Part over a whole. We now know the part. We now know the part. The part is 301. So the rate of inflation. Hold that thought. The rate of inflation is part over whole. We know the part is $301.40. The question is, what's the whole? We have two possibilities for the whole. One is the $2,400, and one is what it started at, which is $2,098.60. The question is, which one is going to describe how it's changed from last year to this year? The $2,098.60, right? Does that make sense? That's going to describe how it's changed. That's going to describe how it's changed. If we go from here to 2,400, it's gone up $301.40. It started life at $2,098.60 and increased to that $301.40 more. That's a massive rate of inflation, is it not? What is that percentage? Oh my goodness! So when I do the math, assuming Natalie got it, 0.1436 is the decimal, which as a percent would be 14.36%. Now, Melanie, you're not going to get very much of a different number than that, because 2,400 is pretty close to 2,090, whatever it was, 2,098.60. It does make sense because inflation is measured from where it started to where it ended. The base amount is how much it changed from last year. So you have to compare it to what it was last year. This is what people are always griping about with inflation. What was it back then? What was it back then? And what has it become now? That's the gripe. That's the gripe. It should just make sense. So, hey, Shannon, go ahead. Yes? Well, we did. That's the $301.40. Because inflation is expressed as a percentage. It's not my call. It's not my dear friend. It is not my call. I didn't make the rules here on inflation. They're not for me. They're not for me. They were set long before I was a glimmer in my parents' eye. Inflation has always been measured as a percentage of what it was before and what it's become. Listen, what's your thought? Go ahead.
You can't use that 301 on like other things to find out the difference between their prices from year to year.
Right.
But you
Right.
can use the same percentage.
So imagine, Shannon, to follow what Alyssa just said. Imagine if house prices went up $300. Would we read about that in the news? If the cost of a house went up $300? Probably not. Because $300 over the cost of a house is a little tiny, tiny piece of it. But suppose a television went up $300. Would you read it? Would you hear about that in the news? Most likely. Absolutely. You probably heard it during COVID, during supply chain shortages. So you have to express it as a percent, because the raw dollar amount doesn't tell you enough. You have to compare it to was the 2098.60. Is that fair? Yeah, so, now, make sure okay, must say anything else. You now see how to try number 3 now. No? Okay. What is the average rate of inflation over both of those years? So in other words, often inflation is expressed month to month, especially during political season. They want to complain about the party in power if inflation is high, the party in power wants to brag if inflation is low. But also, they'll do year-over-year inflation from time to time. So what I want to know is, what single percentage rate would get you from 2,000 to 2,400 over 2 years? So you have to first inflate it to 2023 once using inflation, and then inflate it to 2024 using inflation again. So I want you to puzzle through this. So we're coming up on break. So take break if you need it, and then we'll come back and we'll take break. Walk around if you need to take a break. We didn't do it our way. There's no one way. There's always going to be 2 ways. Hold that thought. When we answer number 3, I think we'll see it. I think we'll see it. And I think people will come around to our way. I could be wrong. I might be wrong. But I think. No. So this is a great question Josie's asking. The percentage rate that we used back in 2023, that 4.93%, off the table. We're starting at $2,000. We're starting at $2,000. We are then increasing it with some rate in 2023, which is going to be $2,000 plus something. Then we're going to do it again, same rate, to get the final result. So it's going to inflate twice. It's going to inflate from 2022 to 2023. And then it's going to inflate again from 2023 to 2024. If this is freaking out, just sit tight. We'll do it together. It's all good. We'll do it together.
That little extra, yeah, that got me.
That's okay.
Like,
It's all right.
okay, well.
It's okay. It's okay. We'll do it together. We'll do it together. And that's actually, the math isn't that bad. The way you're doing it is great and it's very logical. Unfortunately, it falls apart when you have to do anything more than just analyzing 1 year's worth of data. Because it gets too clunky. But that's okay. It's fine. Walk around, get some air, get some money. Yeah, for sure. For sure. Okay. Oh, okay. Yes, absolutely. Oh, I should have paused the camera. They're taking a break. Shake it for later. I'm going to pause this. Actually, we're gonna swing it up here first. Okay. And then pause. How do you pause? I think I hit. Yep, that paused it. Good. Why is it only at 25 minutes? I've been here longer than 25 minutes. That's weird. It's recording. Hang on. Yes, we are recording. Chad just asked a phenomenal question. Why do you put 2023 in there? Inflation happens every year, whether we like it or not. For example, recently, and I built a homework out of this, it's been the cost of inflation of college versus the economy. This is one of the reasons I got thinking about the, what's that? Is it not pointing?
No, it's crooked.
Oh,
Don't
it's all good, it's all good. Let's just point it back over here. Oh, I'm good, thank you. I just drank water and that'll put sugar syrup in my mouth. We're good, we're good. we got a lot of people out sick. Take care of yourselves. I'm trying to record class.
My bad.
For years now, there's been complaints that the cost of college is increasing faster than the cost of the value of the economy. It's becoming more and more expensive. One of the reasons I'm designing that question for COCC tuition versus other schools. You have to be able to track things over more than 1 year, but they inflate every year. So, for example, if we jump straight from 2022 to 2024, we get a percentage, right, Shannon? But that doesn't tell us what happened each year. We're going to figure that out right now. And it's actually, the math isn't that bad. We know that in 2022, the cost starts at $2,000, and it ends up at $2,400. We know it's going to end up down here. Now, let's complete a chart, but we're not going to come up with the percentage for 2023 right away. It's going to seem weird. It's going to seem weird, but I promise it's not going to be that bad. We know that there is an inflation rate, the rate of inflation. Is it cool if I just call that little r for the rate of inflation? Because I don't know what it is right now. Is that cool if I just call it little r? Is that, give me a thumbs up if that's okay? Okay, so a little tiny bit of algebra, so we need a little tiny bit of a variable. So the rate of inflation, I'm going to call it little r. Is that fair? Okay. Now, since I don't know what that rate is, I can't possibly know how much this is going to cost in 2023. But I do know how I would calculate. I would use Natalie's awesome move from before. I would start with $2,000, and then I would multiply. Now watch this move. Watch this move. This is the power of algebra. I multiply it by 1 plus r. I don't know what that equals right now, but that's what it would equal if I knew what r was. Is that fair? James, go.
What would it be +1?
The 1, thank you. It's a great question. Who wants to answer that question before I jump in? Why is the +1 there? Why was the +1 over there? I did it over there too. The 1.0493. We did it over here. 1 plus every place. James, what do you see it now? It's the 2,000. It's compressing Natalie's work into one thing. It's the same thing Natalie did. It's just doing it 1 step versus 2. It's great. It's that 1. Great question. Fantastic question. The 1 stands for 100%. The R stands for the additional percent. Is this fair? Okay. Now, I don't know what that is yet, because I don't know what R is yet, but that's okay. Because what I'm going to do, again, from 2023 to 2024, I'm going to take that out and put it back in a second. Do you agree that whatever this is, it's got to get inflated again in 2024? Which means it comes down. It comes down 2,000. This is still there from 2023, but then it's going to get inflated again. Oh, no. Oh, take a deep breath. Take a deep breath. God, you do too much spit there. You might choke yourself. I don't know if the Hamid maneuver works for spittle. Now, some of you are looking at that and going, Sean, what the hell? Why would you write something times itself again? Why don't we just write it instead as, if something times itself, what say that again, Melissa. Isn't that just squared? It's just squared. It's $2,000 times 1 plus R, the whole thing squared. Is that fair? If we went, and we're going to do this not right now, but later, if we went down to 2025, that power would change to the third power. 2026, it would be the fourth power. So, and we'll get to all that later. We'll get to all that later. We're going to look at minimum wage in the back half of this class. We're going to look at what happens to minimum wage over the past so many years and figure it out from there. You don't have to worry about that. Don't have to worry about that right now. Right now, it's just we're going 2 years. That means the rate got applied 2 times. Now it's multiplied because that's the way percentages work. The whole crux of financial math is multiplication. Because you take money and you multiply it by something to change it, whether it's up or down. Malia, go! The amount which the rate wouldn't, the amount according to the rate would. And this is one of, thank you, dear friend. This is one of the more confusing things about using percentages. Can I give you a side story and then come back? Years ago, I was on negotiations here. Something I swore I'd never do again after this. 2014, 10 years ago this year. A high administrator at this school told me, everybody gets the same raise every year. I said, I'm sorry, what do you mean by that? He said, well, everybody gets 3%. I'm like, you do realize that 3% doesn't mean the same depending on who you're talking about. Like, I would love to get the same raise as the president, for example, who has the highest pay scale in the school. So when she gets 3% and I get 3%, who actually gets more? The president, but it's the same, 3%. You can't go into a store and spend 3%. You can't go into a store and spend 3%. You have to spend a dollar amount. So Malia, the rate can be the same, but even if the rate stays the same, the dollar amounts can keep growing exponentially, which is the whole point of the last 2 weeks of this course. We start looking at the financials. Is that a fair question or a fair answer for now?
All right, I see. Okay.
Whoa, here's no. Natalie's got the. This has to equal something. This has to equal something. After 2 years of inflation on $2,000, dear friends, what does it equal? $2,400. Stop right there. For now, just make sure we understand that. We started at $2,000, and then we inflated it 2 times. What, 2023, and then the 2024. That's 2 inflation rates. We ended up with $2,400. That's the math so far. We're going to solve that in a second. Which sounds awful. Exactly. We're going to do some algebra. Christine, hold that thought. I got you. You're 100% correct. We're going to do a little tiny bit of algebra to solve for that R. That R is buried there inside there, right? We got to get it out. We're going to get it out. I want to make sure let's go through this again. Starting amount. Inflated it. How many years? Right? That's the ending amount. Is this fair? Okay, good. We're going to write down that generalized form in a second before we dive into minimum wage after we get done this form up. Josie, answer that question. You said so. Yes! Hold that thought. Let's solve together. We have to get R out of there, right? We have to get R in a little tiny bit of algebra. And even if you haven't had algebra in years, we're going to relearn this bit of it right now. So here's the equation that we have to solve to get R out. You got it, Josie. Okay, so the first thing Josie realized is, I got to get rid of that 2,000. That 2,000's got to go, because this R is buried in those parentheses. The 2,000 has to go first. Josie had an idea, subtract the 2,000. How is that, and this is where an algebra review, we're going to do an algebra review right now. How is that 2,000 attached